Hello, Algebra 2 students. Today we are going to finish Chapter 2 by talking about an extension section that comes after 2.7. This is 2.7 extension use piecewise functions. So piecewise functions are a topic that you're going to see in pre-calculus. Functions can be represented by a combination of functions, each corresponding to a part of the domain. These functions are called piecewise functions. And recall that domain is your x values, your input. Looking at this first example, you have a function. So remember, f of x is just y. So y is equal to x plus 3 if x is less than 5. But then y can equal 2x plus 1 when x is greater than or equal to 5 for the given value of x. So this particular um, function is defined by two pieces. And the two pieces are given in these braces. So what do we make of that? Well, we use the portion. So there's two linear equations there. There's x plus 3 or there's 2x plus 1. We use the one that is defined by the domain. So if we look at problems 1, 2, and 3 in our table, we have to choose which equation to use based on the domain. And I'll show you how to do that. So this number in here is your input or your x value. So if you look at f of 3, the number 3, is it less than 5 or is it greater than or equal to 5? Well, we know it's less than 5. So because it satisfies the top part, then we're going to use x plus 3. Explain why. Well, 3 is less than 5. Now we're going to take that 3 and we're going to substitute in the value of x and solve. So we are going to replace the x with 3. So 3 plus 3 is 6. So the value of f of 3 is 6. Right. Now we'll do the next one. 7. So we choose either x plus 3 or we choose 2x plus 1. So you go back to the domain. Which one makes it true? Well, we know the bottom one makes it true because 7 is greater than or equal to 5. So we are going to use 2x plus 1. And our reason is 7 is greater than or equal to 5. Can't use the top one because 7 is not less than 5. And so when we replace our 7 into our equations, 2 times 7 plus 1, that's 14 plus 1, which is 15. And then finally, what about when x is 5? All right. Well, 5 is definitely not less than 5, but 5 is greater than or equal to 5. It's equal, so we are going to use the bottom one. Because 5 is greater than or equal to 5. 2 times 5 plus 1 is 11. And that is how you evaluate a piecewise function. Now we're going to graph a piecewise function. So graphing it's the same way. You're going to have two graphs in one. So if you look at this particular one, f of x is equal to negative 2x, or f of x is equal to 1/2 x minus 1. Now it's equal to negative 2x if x is, or when x is less than or equal to 0. So anytime x is 0 or anything negative, you would use the top equation. If anytime x is bigger than 0, but not including 0, so even if you have x to be a 1/2 or a 1/3, all of those numbers are bigger than 0, you would use the bottom equation. So now let's graph. So what we want to do is make a table for each one. So down here on the bottom, I'll make a table for y equals negative 2x. And remember, for this particular one, we can only make a table for we can only pick values of x that are less than or equal to 0. So let's write that down here. That's the domain restriction. So we can pick 0, but everything has to be negative after that. Right? And so a negative 2 times a negative 3 is a positive 6. A negative 2 times a negative 2 is a positive 4. Negative 2 times negative 1 is 2. And negative 2 times 0 is 0. So remember, I took each of these numbers for x and replaced them right there. Right? And we can graph that now. So let's do negative 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Negative 2, 4. Negative 1, 2. 0, 0. But you can't go past 0 because remember, we cannot pick x to be anything bigger than 0. So this is our graph. But arrows only go in one direction only. Can keep going that way, but just can't keep going past the 0 because then you get into x values that are positive and we can't choose those. Okay, for the second part of our graph, and I'll do that in a different color, and I'll put it right here. Y equals 1/2 x minus 1 only when x is bigger than 0. So when we make a table, we want to pick values, and we don't even have to make a table. We can just graph this using slope-intercept form. But I mean, I think it makes sense to make a table, so let's make a table this time, just to pick a couple of numbers anyway. Okay, so we can't pick 0, but you still want to put 0 in your table. I'll tell you why in a second. But you can pick any number bigger than 0. And oops, we probably should have put 0 over here. Okay, so we can't pick negative numbers, so 0 can go here. Let's pick multiples of 2, so 2 and 4 because we have a fraction, and probably 6 too. Okay, so 1/2 times 0 is 0, minus 1 is negative 1, but you can't graph this, so no, because remember, x has to be greater than 0. Okay, 2, 1/2 times 2 is 1, 1 minus 1 is 0. 1/2 of 4 is 2, 2 minus 1 is 1. And 1/2 of 6 is 3, 3 minus 1 is 2. Okay, so I'm going to plot the last 3 points. So 2, 0. I'm going to show you something in a second. 4, 1. 6, 2. And so on. Can keep going this way. But, however, notice we can't pick 0, but we could have picked a 1/2 or a 1/3. So even though we can't pick 0, so 0, negative 1, do we put a dot there? No, we put an open circle saying that that's not included. Okay, I didn't do a really good job at making an open circle. So let me try again. There. But these values could be picked, just not that one. So you indicate with the open dot that 0 does not belong in there. So the point 0, negative 1 doesn't belong, but anything else does. And that's how you do that graph. Okay, so the next one is just a bunch of horizontal lines. And how do I know that it's horizontal lines? Because earlier in this chapter, y equals any number is always going to be a horizontal line. So this is y equals negative 1, y equals 0, y equals positive 1, and finally y equals 2. Okay. And these are your domain restrictions. So this is anything greater than or equal to 0 but less than 1. This next one is anything greater than or equal to 1 but less than 2. Anything greater than or equal to 2 but less than 3. And finally, anything greater than or equal to 3 and less than 4. Right? So now let's graph the equations. So the first one, the stipulation is from 0 all the way to 1. Okay, so we're going to plot a horizontal line at the y-intercept, y equals -1. So right here, but only between 0 and 1. So here's x is 0, here's x is 1. So greater than or equal to 0, but less than 1. So open circle there. And that's the first graph. I'm going to do all these in a different color. The second one, greater than or equal to 1, less than or equal to 2, or less than 2. So here's the number 1 right here. Here's the number, oops, I'm going to make a little mark here, number 2 right there, or x is 2. So that's the equation. So you can make a closed dot here, open dot at 2 because it's less than 2, not equal. And then here, connect them. Okay, the next one is between 2 and 3. Oops. Here's the number 2. There's 3. So here's 2 and 3. So um, including 2, but not including 3. And then lastly, 3 and 4. Where am I getting these 3? Where am I plotting these numbers? So and I can show you. So this is 3 and this is 4. But why is it up here that we're making it? Because the equation y equals 2, this is, remember, this is 1, 2, 3, 4, 5, 6, and so on. So we are plotting here. We're including 3, but we're not including 4, because that's what less than means, not including. So this is called a step function or piecewise. We use this in the postal service. Like if you're mailing a package, if it's 1 ounce or less, you're going to pay a certain amount for your postage. If it's between 1 ounce, um, if it's right at like a 1 point whatever ounce to something, then you pay a certain amount. So that's a real life example of a step function. And then this last little bit, we're not going to really worry about. We're not going to do the writing the equation. It's a little more advanced, but this is how you would do it. If you were asked to write an equation, you don't ever have to do it. You would divide this graph into 3 parts because notice you have a slope that's decreasing from here, from this arrow, oops, all the way to here. The slope is decreasing. So I'm going to draw like a squiggly line here saying this is the first dividing. The next part is a horizontal segment. So the slope is 0. And so I'm going to draw another. And then lastly, you can see the slope is increasing. There you go. And so the first thing you would do is you would divide the graph into 3 sections or 3 graphs. You would find the slope and restrictions for each graph. This would take a lot of work because you would have to write the equation of the line. The only part that would be easy would be the horizontal portion and write the function. So this part would have 3 parts, and we know y equals 1 would be the, oops, I'll make it y equals 1 in blue because that is my horizontal line, and it's between the x values. So remember, this is 0, this is -1, -2, and so on. This is +1, +2. That blue graph is between -1 and 2, and including those two, because there's no open circles. So it'd be -1 all the way to +2. And that's how you write that one. The other ones we're not going to worry about just because you'd have to write the entire equation of a line. So um, we're just not going to worry about it. So I just want you to be aware that this is an example of a piecewise function as well. And those are your notes for today. Have a great day, Algebra 2 students.